This chapter is, of course, chapter 9 on Venus. Just a couple of quick things. First of all, Venus, you cannot see you can't see the surface of Venus, I should say, from the Earth, or even from, a spacecraft that's in orbit around Venus. And the reason is the clouds are so thick that there's no way that visible light passes through the atmosphere, the very thick atmosphere, which is made mostly of carbon dioxide. This image here that we're looking at was taken actually with the Magellan spacecraft many years ago, and it actually mapped something like 99% of the surface of Venus. It has mountains and valleys and plains. There is actually evidence, very early evidence, that there was once liquid water on Venus. That's, of course, all gone because this is the hottest planet in the solar system. It is because of that very thick atmosphere that I mentioned. The density of the Venusian atmosphere is roughly 100 times the density of our atmosphere. So, and the fact that it's made up mostly of carbon dioxide means that it holds on to its heat like a greenhouse. In fact, it's what we do call a runaway greenhouse effect. All right, so these are some of the properties that we're going to talk about. A lot about the atmosphere and other things. So Venus is a particular, when you just look out, without binoculars or a telescope, it's actually a very bright object. It looks like a star. Of course, it's not a star. It's a planet. It's certainly within our solar system. Of course, it's the second planet from the sun. And the other thing about Venus is it is the closest planet in the entire solar system, closest to matching the size and the mass of the Earth. So it's almost Earth's twin, actually, it turns out, but it's quite a different world. So the thing is, of course, Venus, and just like Mercury, is closer to the sun, and so that we really only see Venus during very close to sunset, right after sunset, or just before sunrise in the morning. And so it's usually called a morning star or an evening star. Of course, it has nothing to do with being a star. It's a planet. But, the ancient people didn't know that. It was just a bright light in the sky, and so they called it a star. All right. So of course, Venus undergoes phases, and that's just because it's between us and the sun. And so we're seeing Venus at different angles between the changing angles between us, Venus, and the sun makes for phases, just like the phases of the moon. You can actually see these phases with a telescope. Even Galileo, 400 years ago, noticed that Venus underwent phases. You might recall there's no way to explain that using the geocentric model, where the Earth is the center of the universe. Only a heliocentric model works to explain this observation. All right, so let's take a look here. There's the radius of just slightly smaller than that of the Earth. The Earth's is 6,400 kilometers, and the mass is almost 5 times 10 to the 24th. The mass of the Earth is about 6 times 10 to the 24th. And notice the density. We don't usually use these units, by the way. It's usually in grams per cubic meter. And so for Venus, it would be about 5.2. Now, here's here's two really interesting facts about Venus. Its day, the period of rotation, the period that it takes to spin around its axis, is actually longer than the time it takes to go all the way around the sun. So one day on Venus would be longer than its year. Not only that, and this gets even stranger, unlike most of the other planets in the solar system, all the planets go around the sun in a counterclockwise direction. So does Venus, but most planets like the Earth and Mercury and Mars, for example, also spin in a counterclockwise direction, spin about their own axis. Somehow something happened to Venus long, long ago, and it's actually spinning the other way around. It's actually spinning clockwise. So that's a kind of interesting. It's almost completely upside down, basically. All right. So there's lots of theories on why that is, but probably the theory that works out closest to what's observed is that something hit it long, long ago and got it to flip over. All right. Anyhow, we're still working on that. So it has as I said, it has a very slow rotation. Yeah, so that's basically all that it's saying there. Yeah, all right. So again, going back to this thick atmosphere, so it is extremely dense. At the surface of the Earth, we measure the atmospheric pressure to be 1 atmosphere for that's obviously we use the Earth that way. Mars, for example, we're going to talk about in the next chapter, has a much thinner atmosphere. It's roughly 100 times thinner than the Earth's atmosphere, and for Venus is almost the opposite, almost 100 times thicker. On the surface of Venus, it would be about 100 atmospheres of pressure. And it's also the hottest planet, as I mentioned earlier. It's sitting at the surface is roughly 730 Kelvin. So it's even hotter than Mercury, which of course Mercury is much, much closer to the sun. But it's really because of this runaway greenhouse effect. We'll talk about that in just a little bit. Let's see. So that the various space probes over the years. Actually, I think back in the 1970s, the Soviet Union sent a spacecraft. believe it was in the 70s that actually landed on Venus. It was called Venera, one of the Venera spacecraft. I think there's actually some pictures of that coming up here. The surface is relatively smooth. And here's an interesting fact about the surface features on Venus. Venus. The surface features traditionally have been named after either female mythical figures or actual human women, figures from history. And Mars is the opposite. It's usually named after a male. Not completely. I mean, there were some features on Mars that were named before this. All right. So anyhow, we see no evidence of tectonic plates. There are mountains and craters and volcanoes, and that show evidence that there was lava flow in the past. We haven't seen any lava flow. This is actually a nice feature. This is, of course, is in false color. This is from the radar images, and so we took the radar images and put them into computers, and you can see, it's kind of it looks like the blue are oceans. Of course, they're not oceans. There's not a drop of liquid water on the surface of Venus because, of course, it's so hot. Water would just vaporize. It would just boil away. All right, so we think that there were oceans, or at least liquid regions, lakes, or whatever on the surface of Venus long ago, before that runaway greenhouse took effect. And all right, so so this is just showing you a map of Venus. Okay, again, it looks very similar to the map of the Earth, but don't forget these are the blue areas are definitely not oceans. All right, so what else? This is what's called Ast101 and that is a very famous. Well, I don't know how famous it is, but notice, if a surface feature on Venus, and then here's another one named Cleopatra. All right, Aphrodite, Aphrodite Terra, or that's kind of a close-up of it. It kind of looks like lava flows there. This is actually a nice looking. It shows like lava, cracks in the surface where lava once flowed. And this is not recent, of course. We don't know exactly how long ago, but we don't think it's very recent. Here's an example of a mountain. This is called a shield volcano. Oh, sorry, it's a volcano. This is called a shield volcano. And there are actually shield volcanoes on the surface of the Earth. The name comes from long ago when soldiers used to carry shields, and if the shield fell, and the roundish part of the shield was pointing up, that's kind of what somebody noticed that kind of looked like a shield on the ground, and so that's how these things got named. The shield volcanoes, that is. All right, so let's see. So this is another. This is not hot lava. Okay, this is just showing some domes, some coronas of that have solidified long ago. All right, let's see. There's an impact crater named after Margaret Mead, who I think was an anthropologist, very famous anthropologist. All right, yeah. So, here's the Venera landing. So this was a Soviet era spacecraft that landed, and it only lasted for about 2 hours before the electronics completely burnt up. But notice the pictures are actually very similar to pictures that we have of Mars, of the surface of Mars. There's rocks and boulders and things like that. Here's just a graph of the atmosphere showing that it's extremely dense in the atmosphere. There is sulfuric acid in the clouds, as well as it's mostly carbon dioxide, of course, which is a major greenhouse gas. All right, so the upper atmosphere of Venus has extremely high winds, very high winds, in fact, that we still really need to explain because Venus is rotating very, very slowly. So why are the winds moving so quickly? That's a ongoing question that we're still trying to solve. There are actually vortices, so these areas at the poles of Venus. We see this actually in other planets, as you'll see. Saturn has some vortices as well, and this has to do with well, we think it has to do with the rotation, but again, Venus spins about its axis so slowly, it's kind of strange that these things would be appearing. So this is just showing these vortices a little bit better. Let's see, Venus. So this is the thing I was talking about, this runaway greenhouse effect. So as sunlight comes in and heats the ground, that sunlight gets completely trapped and does not